You. All right, hopefully students have joined in, not yet. And I'll open this up. Get all this stuff started. Go to HDMI. Why is not on? Oh, there you go. All right. So this is what you see, what they see. But then I'll share the screen. Nobody's on yet. Oh, okay. Caleb, Mr. Boudreaux, he's on getting on. All right. Now, Mr. Anybody questions? The assignment. Because you had two assignments, right? One dealt with vectors, which we didn't kind of go over, but if you read your notes, you know. And the first one was dealing with the two-dimensional array. Mr. Booker has issues with his. So you have your laptop with you, Mr. Booker? Yeah, going on and pull that up or whatever, and we could look at that. Anybody else with issues with the program, or you know, like even yes, sir.
I mean, I just got a desktop. I just bought a desktop. I didn't like dealing with Mac.
Yeah, going back because I don't know if it was you or somebody said, and it's like I say, you probably could watch a YouTube video or something.
I took one of your classes last time.
Okay, yeah, and then Mac, there a lot of times you got to do a lot of different things. Yeah.
Like what you were doing.
Showing, right.
What you were showing, I was having
different
to, like,
to learn all over again. Right.
So I downloaded desktop. Visual Studio last night, but I don't know. I'm still.
Oh, you downloaded the community version?
Yeah.
Yeah, okay. Now, once you download it and you open it up for the first time, it will not have, I don't think C++ will be the default.
Yeah, they didn't have it at all. How did you, they had C#.
Oh, no. Well, yeah, you didn't, because there's some check boxes. Normally,
I can watch the YouTube video
and download it.
That YouTube video, it was one of the first ones.
Right. Because yeah, over on that, I think the left side, when you click, it give you all the available your apps.
It had strictly, and then you know how you did search. You know,
right.
It strictly had C#.
Okay. What version you downloaded?
At first 17, but it didn't seem like it was the right one, so I downloaded 19.
Okay, you could have did 17. 17, I had a link. When you log in to sign the room, I have a link there for the old 17 version.
So I could use the 17, it'll be fine.
Right. No problem.
I'll probably go with that link.
Right. And like I said, you could try it while we're in class, you know, if you got your laptop.
I bought a desktop.
Oh, you got a desktop. Okay.
I'm probably gonna get something else.
Right, okay, right. Because that desktop, that means you're gonna have to be home to do it.
Exactly.
Yeah, that's tough.
I'll probably end up getting something.
Yeah. Okay. Anybody else? Question. All right. So, Mr. Booker, you pulling yours up? Okay. Now, so like I said, the program, the two-dimensional arrays, one, you add it going across the rows, and the other one you add it going down the column. The only thing you had to change in the program was the nested loop in the calculation function. Everything else, and you know, in the output, you know, because the ones going across in rows, you're outputting on the right, and with the one for the columns, you're outputting at the bottom of each column. So that was the only difference in the two. All right, but they both, you know, same practices or whatever. All right, with the vectors, if you read through the notes, vectors are like arrays, all right? But they're a little different. With vectors, they can grow and they can shrink. With an array, once you declare a size of an array, that's it. You know, you cannot increase the size, decrease the size of an array. You allocate the space, and that space is there until the program, you know, finish execution. With vectors, you can grow it, you can shrink it, grow it, shrink it. So what? You're utilizing the maximized space on your computer when you do it that way. Now, also with vectors, if you did your program with vectors, if you create a vector, all right, and it's null, say no, nothing in it, it's empty. Then anytime you want to put something in it, you have to do the pushback, okay? You have to do the pushback. But if you create a vector and give it the elements, the size of the elements, then you just treat it like an array, okay? You just treat it like an array. So, and I'm saying that because if you created your program, your vector program, and you created the size of the vector as 10, and then you still use pushback to input your data, your inputted data won't be at sub 0, sub 1, sub 2, sub 3, sub 4, sub 5 to sub 9. It's going to be from sub 10 through sub 19. And you're going to be like, well, Mr. Vessa, I tried to print my vector and it's showing nothing, right? Because what? There's nothing in those first 10 elements of the vector because you created it of a size 10 and you did a pushback to add to it. So you got to be mindful of that when you're dealing with vectors. All right. What's up, Mr. Casimir? All right.
Hello, yeah. Professor. How you doing?
All right. We all doing fine.
Yes, sir.
All right. So you got it up, Mr. Booker? All right, bring it up here, Mr. Booker. So class, what we'll do, put your computer here. Okay, let's see. You got a USB port? I think you should have one. Yeah, okay. So plug this to the USB. Okay. Should come up. Now what's happening? Let me see something. I'm not sure. Should be coming. No. I wonder why. I wanted everybody to see that it's connected. Oh. Okay, they should have an input signal. There is no control for this device. So we can't do it here. All right. I wanted to do it as a class. Look like it's not. Just leave it there. Let's see. All right. All right. So. Okay, mine just come up. All right. So I have Mr. Booker's assignment. He got it in Visual Studio. But for whatever reason, it's not reading his data file. All right. So in his header file, he has the F string. In his .cpp file, he got F stream in data. Okay. And in his get file, he have in data dot open and in double quotes data underscore cb dot txt, which is correct. So and when he running, all he getting is the addresses. So what I'm gonna do, I'm gonna look at the data file. Data file looks good, everything is in there. So let's see how he's reading it. He's doing in file. Okay, yeah, okay, got it in this nested loop, X and Y, and he's reading in score or SCR sub X sub Y, and that loops until it ends. All right, so now, let's see what happens. Let me create another data file, all right? I'll just create one, add, new, and I'll say utilities. This is how you created it. Text, and I'll say sample. And y'all can't see my see the screen. .txt. All right, so I'll add that. Wow. I got a question, Mr. Booker. I don't know if it's causing an issue or not. But you name your project, what it ran though, 1943.1A. When you put a dot many times in a file name, the next part is the extension. And sometimes, in most applications, sometimes you take away from the purpose of the file, if you understand what I mean. Like some applications read a file for what it is. Some applications read a file for what the file name is. I'll give you an example. I could take a photo, right? And it's in .jpg, right? A JPEG. And I could open it up in certain photo editors, and it's gonna know that it's a what? JPEG file. But if I take that file and change that extension to, like, say .bak, some applications will still open it as a picture file. Other applications will say, oh, this file does not seem to be the right type file. Because what? Not because of its contents, but because of what? The way it's named. So that might be an issue, I'm not sure. So, we need to check that out. But let me add this and see what happens. So I have a blank file. If I could tell you. So I'm just putting in some fictitious numbers. And I'm gonna see if it just actually read the file. Okay, so I'm gonna just copy this 5 times. Oh man, what do I do? Okay, so I have that. So now the name of the file is sample.txt. So I'll go back to the file. I'm gonna change the name to sample. If I could tell you. Close that. All right, so now we're reading sample. So whatever we're getting it, wherever we're getting the data from, we're getting it from sample. So now I'm gonna compile it and see what happens. Yeah, I'm gonna compile it, see. One succeeded. And let's see, debug. Come see. Now, it printed the data, class. So it might be the way you created the file. You understand? See, look. So you had the code right, but if for whatever reason, the way you created your data file, it couldn't pull it in. Or you probably just created it in another folder and said, oh, okay, I'm gonna just reference it, whatever, but it's not referencing the right location. But what I did, you saw, well, you didn't see.
No, but yeah, because I went, that's
Right.
same thing. I went
Right,
over
so I
there
created it.
and did it through the source file.
Right.
Add new
And
like you said,
text and utilities,
utilities.
and then the TXT file.
And
But you see what I did, and all I did was added it, created it, added the data, changed the file name to sample.txt, and it was. So what you do is you could delete the other one, rename that one, and then work with it. Work with that. Same issue.
thank you.
It give me like memory addresses when you're trying to output the data.
Yeah. Well, just like give me the error saying I can't declare in data.open.
Okay, no, now with that, you probably trying to open the file in the wrong location. What folder you opening the in data file? When you getting it?
Yeah, when I get it.
Right, but did you do the F stream or IF stream in data at the top?
Yeah.
Oh, you did that. Did you use F string, pound include F string for file, loading of, that header file?
Yes, sir.
Oh, you did all that. Okay, so let's see.
And this is the thing that I'm declaring.
Okay. Yeah, see, you got it in the wrong location though. You need it where you're getting your file. So you're gonna open it when you are in your get function. So you need to cut this and paste it in your get function. Not all of it. Just that one, right, just that. Just that line, the whole line. Right. Kitchen. Right, cut it, well. And then go to your get function. Yeah, see, you got it.
Yeah,
Right, so you were trying to open it twice.
okay.
But then the first place, you can't open it out there because you're outside of the program. You know, you're outside the execution of the program. So you gotta open it when you're executing the program. So that should take away that error. All right. Okay. All right, class. Now, any other issues or whatever? Chapter, oh, you got it?
No, it's still giving me an error.
What it says? Did you compile?
Yeah, I pressed compile. Now look at.
What is the use percent on? So. Double click on the undefined local variable. What's up, Ms. Dover? Man, we need to do some of this air, man. Bro, I'm in the sauna every day I come here.
How y'all doing?
Man, I be sweating down my leg, my back, and everything. Like I'm outside working.
They work.
I'm gonna start sweating, so you gonna see it wet here in a little while. Man, all right. So what it say? We gonna do something? Show that line, show it. See? Whoa,
Mr. Sylvester, you want anything in here?
In average.
You
Man,
want anything in here?
not that I know of.
Can we
Just
just go
just
this
take
way?
them white side of that and that,
Ain't no white.
yeah, and that,
It's screws.
that spring. And that, what that spring, that, window. 15, let's see. Go back up. You got in average, right? Okay. Now, you use an average here, but you have a function. What is your, go to 28. All right. No, this is wrong. You want to open your data file. You don't want to open and stream your array. You know what I'm saying? You want to do whatever dot open, and in parentheses and double quote the name of the file, which was we just copied, what we just cut.
So overall data.
Right, correct. So what you're doing, you open it so it can be used. Then after that, you're gonna read in score, so X and Y. You understand?
Yeah.
Well, yeah, you gotta make sure you well, do a page, highlight that. Remember you cut it. Remember?
Okay.
Highlight on 3 times. And page.
Do I need to do it? Help
All right, so that's gonna open, but now you need that other statement to read it in. This outputs it, but now you want to read it in. Then you output. You know, that's just your little test, you know, that's how we had the class. So hit in after that. And now you wanna, input, read in your, scores of X of Y. In that, with your stream, scores of X of Y.
It was on the inside or outside.
You wanna read in your scores of X, of Y.
It's like some others.
So you're gonna use index, which is a file object. And then you, no, and you stream it with the, greater than sign twice. That reads it in. That's print number. Right, then scores of X of Y. And that should fix that problem. Okay, in there. Yeah. Hey, I need an adapter for this thing down there. Cause it's I need a female VGA adapter. I don't know if Ryan had one. I thought I had one at home, so I could use that board there. Well, you know they changed all this, so the connections is different. All right, did it remove that error?
Yeah.
All right, so now you might have another error, right? That's normally how it works, right?
Yeah.
You fix one and now you got some other type error. So you got to make sure your logic is correct. So now, anybody else with some type of issue?
I just have a question.
Yes, sir.
What I do for the vector, to make sure all the decimal points lined up, what I did, I just tabbed everything over it, but I wasn't sure there's a specific code or thing we're supposed to put in to make sure all the decimal points are.
Okay, what not? To do that, if you remember 1933, we used the IOMAN IP header file, and then you got but then you got left and right. So if you say you do the show point and you set the precision to what it was.
I set it to
Okay, that was on what assignment?
second.
Yeah, okay, yeah, that
The
vector.
and
You set it to 2, and then what you do, set it to right when you outputting that value. So every time you outputting a currency amount, it's gonna line up when you set it to the right.
Oh. Okay.
Right.
So you would do fix, show point, set precision 2, and then just add
Right. Cause see now, you're right. Cause see if you do, anytime you set the alignment left or right, it's gonna stay until you change it the next time.
Okay.
So if I do an F stream a name and I say left, and I want to F stream the number and I want it to the right, I got to put right before I output it.
Yeah, because they were all lining up when they were all like, say, like $12.
Right, when all was even.
Like 8
Right.
or something.
100 and something, then it's there,
Right, yeah.
changes that. Right. And that just for format purposes, because you're gonna notice over time when you writing code or whatever, you don't want your output to just be what all over the screen or set up some kind of way where people got to figure out if this is this, if it's uniform and whatnot, and it looks good, then you know your program will stand out. You know, it'll stand out.
Thank you.
All right. Okay. Any other questions? Now, Mr. Booker, you got you straight? All right. So now let's look at chapter 8. Chapter 8 deals with searching and sorting. Now, like I said, the class is kind of going to be a little different in that. Let me go to the share my screen. In that, like I said, you're gonna be reading a lot of your information, but at the same time, like I said, you got the book, so you can read the book, but you can also, when you're doing my assignments, you can go to the website and look at the specific information that I'll be using for you to do the assignments, all right? So this is specific information toward what? The assignment itself. It is the content of the chapter, but it also focuses on things you need to do for the assignment. You don't have to try to go through the book and try to read through it to get to something, you know, okay, linear search, that's gonna be in one of your programs. You understand? Stuff like that. So it's gonna have that information, you know, in this, but you got the book content because you still gotta take what? The test, okay? All right, so chapter 8, let me move this on. Okay, so here we go. Can I open this wide? Or might have to just download. Cannot play it, cannot play it, cannot play it. Play it. I'm gonna just download. All right. I download it to. All right, and I'll just open it so the whole screen is shown. Oh, it's the same thing. Is this a PDF? All right, here we go. I should have did it the first time. All right, so here we have this information here. All right, so now chapter 8, searching and sorting. All right, so the book talks about our search algorithm. So you're gonna have a program dealing with a linear search and a binary search. All right. Now, in short, the difference of the two is a linear search is like you searching for a song on a cassette tape. Okay. You have a cassette tape and you're at the beginning of the cassette tape, and the song you're looking for is, say, the 6th song on the tape. What you have to do? Fast forward through the whole thing. You can't skip over anything, right? So you'd have to go through the whole thing, checking to see if you get to the song, right? That's a linear search. And that's the same thing here. So a linear search here is just like saying if I have an array of 10 numbers, all right, and I'm looking for the number 5, I'd have to check to see if the first position is equal to 5, the second position is equal to 5, the third position is equal to 5, the fourth, you understand? Till I get to that value. So I got to what? Go through it one at a time from start to finish. So if I don't have enough, that number, if that number is not found in that list, I have to exhaust what? Every possibility, right? So the larger my list, the what? More computer time it takes. You got what I'm saying? So even though the linear search is good, it what? With large sets of data, it can what? Hog up a lot of your memory time. I mean your computer time. All right? But it works. It just be longer. So it's good for like short searches. Your binary search, on the other hand, it's a search that says, okay, before I search, I need to get my data in order, okay? I need to sort my data, all right, from low to high. So what you have to do, you got to know how to do what? Sort, and that's in this chapter 2. So what you do, you take your list, you sort the data, all right, from low to high. Now you have a number you're searching for, and what you do, you don't just start at the first one, you cut it in half and start at the middle. And if the number you're searching for is higher than the number you add, then you check what? The higher half. If it's lower, then you check the lower half. So see how you just cut down your search bar in what? In half. And what happens, you keep doing that over and over. Because if the number is not found in the lower half and it's possible to be found in the higher half, what you're going to do there, now you're going to cut that in half and search the whatever half and keep chopping it in half and half and half, which reduces the time for searching something considerably. All right. So that's your binary search. So that's just the general of it, but let's look at what it says, and this is somewhat without what I just said. You know, the linear search, a simple search, and it uses a loop to sequentially, means step by step, through the array, steps through an array. All right. It starts the search with the first element and continues on until it finds it or either exhausts the limit of the array. All right. Compares each element. All right. Got to compare each one until it reaches the end or it encounters it. Okay. Then here, and like I say, with your program, here's the pseudocode. So if you don't quite understand what, and I'll show you what this is, because this is, oh, if I can't, I have no page up. Oh, I do have page up. Okay. All right. So this is the actual code, all right? So if you writing your program, you're writing a module, right? You're creating a function. This is the code for the linear search, right? So now, as a programmer, you're gonna learn that many times you're gonna, how do I say, you're gonna have to become some sort of an expert at injecting or inserting code that's already created into your code. You understand? Because you don't want to what? Reinvent the wheel. So many times if you're doing something and somebody has already written that module, you will have to take that module and insert it in your code and it works, rather than you trying to figure out, oh, it does this, it does that. No, get that module, know what the variables are, or whatever, you're returning anything or whatever, and set your program up to where it can accept this. So this is the code. So if you look at it, it's step by step. But let's go back to the pseudocode so we can kind of understand what a linear search is. So here, when you get into that module of a linear search, it's showing you set found equal false. So what that's saying is, before I start checking or falling into a loop to search for my value, I'm gonna say what? The value is not found. You got me? So that I can fall into the loop to start searching. Got me? So you set the value to false, or found to equal false, right? Set the position to -1, because what? If it's not found, you don't want to give it any of the positions in the array, because that means what? It's found, correct? So you set that to a -1. A -1 is outside the boundary of what? Of your array, correct? Now, then you start your index, set index to 0. So you're starting from 0, going to what? The max size of your array. So it says, while found is false. So as long as what? I haven't found what? The value in each subscripted array position, I'm going to do this, okay? So as long as I haven't found the value, I'm going to what? Do this while this information within this while, right? So while it's not found and number of, and it's less, an index is less than number of elements, because what? You don't want to just continue searching. If your elements or your array size is 100, you don't want to continue past 100 or past the 100 element. You don't want to take the 1,000 element or whatever. You're outside the boundary of your array. So you're checking to see if it's found, or you've reached the end of what? Your array, right? Kind of like looking through a folder file. You started the first one, okay, until you get what? To the last one. After that, it's no more search. You want to either move to something else to do or whatever. So now, but if whatever's in the list of index is equal to that search value that you're trying to find, all of a sudden you change and found to what? True. Hey, I found it. Then I'm setting a position to whatever index position that value was in. So for instance, if I was looking for the number 5 and number 5 was in the index position of 4, like say my list array of 10, and it was in sub 4. So when I found it and it was in the fourth, not the fifth element, which is sub 4, then I could swap false found to true, and then I'll set my index, which would be 4, to the position. So now I know where that position at, where the value was found. All right, then I can get out and I can return position. So when I return back to my main program, I can say, hey, I found that the number 5 in that fourth element, in that fourth index of 4, and then reference your array and print out what? Whatever list or score or whatever sub 4, and that's the value. You understand what I'm saying? Or do whatever you have to do with it. So that's what this algorithm is. I mean, yeah, this algorithm is. And like I say, this is pretty much the actual code, all right? So the code would be you're setting the index to 0, all right? You're setting position to -1, and you're setting found to equal false, all right? Same as what we did with the pseudocode. We talked through it. But while index is all right, is less than the elements, number of elements, which is what? Depending on the size of the array, right? And not found, right? Not found would be what? The what it was, the found. So long as not found, long as found is not true, we're gonna continue through that loop. So that's a what we call that. You have the and the or, remember, but that's and. So both has to be true. All right. If the element, if the index number or the is less than the number of elements, all right, and not found, you're gonna continue to search. Continue to search. But if one of them is true, if I find the value, I'm kicking out. Or if I pass the limit, or well, that's the found. If I find the value, I'm kicking out. Or if I pass the limit of the size, I'm kicking out. All right, so that's what that is. But once I find it, right here it says, if list sub index, all right, whichever that value is I'm looking for is equal to, well, the value in the list is equal to the value I'm looking for. Now I want to change what? Found to true. I want to change my position to equal to my index position. And then I'm going to return my index position so I can print out either that row of information or whatnot. Now, you got to understand in these assignments here, we're doing parallel processing. Now you might say, well, Mrs. Vesta, what you mean by parallel processing? We have, in the programs I'm gonna give you, you're gonna have several arrays, all right? I think you're gonna have the name or the ID, the year, and amount. Each one of them gonna be of the same size, right? Separate arrays of the same size, maybe different data types. So when I read a file, when I read sub-zero, the name, or name sub-zero, year sub-zero, and amount sub-zero, that's all pertaining to one record. You understand? But then when I read name sub-5, year sub-5, and amount sub-5, that's pertaining to a whole different record. So when I pass position back to the main function, and I pass a 5, it's gonna say what? I could print names of 5, I could print years of 5, and I could print amounts of 5. So I'm processing. Yes.
Professor, that's actually something I wanted to ask you today, because
Yeah.
in the homework assignments, every record has a string, an int, and a double.
Right.
So I don't know if you wanted us to put everything into a 2-dimension string array.
No.
If you wanted 3
parallel.
different arrays.
Right, parallel, right. So
Okay.
you're gonna be working with them in parallel. So when you find the stuff, like if you're looking for a value in the year and you find that subscripted value, it should align with the name sub whatever and the year sub whatever. Right. You got
Okay,
okay,
understood.
Right. Okay. All right. So that's the code. And now this is just information telling you the advantages and disadvantages of the linear search. Okay. So like I said, linear search is good for small programs, quick and easy, boom, done. All right. You don't have to what? Reorganize the data or anything, right? You're gonna just check from the first one all the way to the last one if it has to. But if you have a large list to search, it can be what? It can be a memory hog. It takes up time and space, all right? A lot of time. And it just shows you or tells you, depending on, well, not here. Yeah, depending on the number of searches, you'd exhaust every last search depending on how long it is. But this one dealing with the binary, I think. No, that's a linear. All right. Now, so it'll go through it X number of times. Now, the binary search, all right? Now, class, grant you, there are many different types of searches, right? But these are the ones that the book has and that we're looking at, okay? But there's many different types of algorithms for searching, sorting, etc. All right? So, the binary search, we did the linear search, step by step by step. The binary search is another algorithm, all right, that is much more efficient, all right, than a linear search, all right? And you can read through it. I talked about it. It cuts it in half. Let's look at an example, all right? Now, this is just a pictured example. We have a list of 18 elements, right? We are looking for the number 83, all right? If we had to go use the linear search, how many times we would have to do we would process that loop?
15?
Right, from 0 to 14, which is 15. Because what? I'd have to check to see if 10, check to see if 18, check to see if 22, check to see if 38, check to see all the way till I get to this one, right? So that linear search, you'd have to check all of them. The only thing different with the linear search and the binary search is the what? The order. A binary search, you have to do what first? Sort the data. Got to keep that in mind. Otherwise, it's not going to work, correct? If you don't sort the data, the binary search will not work. Now, let's see why won't it work if you don't sort. So if we look at this data is sorted from low to high. So when we go through it, we say, okay, we cut it in half. It cuts it in half and says, okay, 83, I'm at 60. Is that less than or equal to? No. So now I disregard that side, and now I'm checking only the high side. You got me? Then it goes here, and then look, is 83 less than or greater than 80? No, but then what? Now I go the next high side. So see how I keep cutting it down till it get to that 1. And if that 1 is not, then what? It's not there. But if you get to that 1, eventually it should be the result. But look, 1 process, 2, 3, 4. So see, whereas the other one took what? 15, this one only took 4 steps. All right. And like I said, the larger it is, the more efficient it would be. Right? Okay. So now, again, this is the pseudocode. This is what you would look at to understand what? This code here. So this is your code. Let me go down here in this mouse here. Yeah, so this is the code, right? So this would be the actual code, but the previous page has what? The pseudocode. So if you want to kind of understand what was going on, you could go back to the pseudocode and look through it and say, oh, they're saying we do this still. Oh, this is done here. And then you could go back and look at the actual code and say, oh, I got it. This is this. So what happens here, notice what they have. They have a function. So they have the whole function created. They call their function binary search, all right? Now, grant you, before you do the search, you must do what? Sort the data, right? For binary, you got to sort it. But look, now we're dealing with only one array because remember I told you the other arrays, we're dealing with them in relation to the elements, okay? Everybody understand that? We're doing parallel processing. So whenever I find a record at sub 5, I know the array in the other array sub 5, all that information is the same. All right, but when we get to the sort, I'm gonna show you how you're gonna have to manipulate each individual array, or what your data can be what? Jumbled. How many people, and then I'm gonna get back to this, how many people have ever sorted something in Excel? So you had some rows of information in Excel, and you did a sort, and it just only sorted that one column. What did you just do? Huh? Yeah, but what did you just do to your data? No. You mix the data up, because if I have the student's name, if I have the student's address, if I have the student age, if I have the student tuition amount, if I had the student's zip code, and then I'll go to age and just sort age from high to low, I done just threw everything off. Now, some of them might still be correct by chance, but what? All that data is what? No good. And you understand? So what? When you sort, you gotta sort. If I move, and we'll get it. Well, if I move element 5 to element 0 for the age, I'm gonna have to move from the name what? Element 5 to element 0. I'm gonna have to move for the amount, element 5 to element 0. So you understand how you got to make sure I move everything in respect to what I'm doing with that one. Right, but you're using parallel processing. What I have some students do, what they'll say, okay, well, Mr. Vester, I can do structure. I would do a structure or class, and I'll just move one, and it's gonna move. Yes, that's true, but I don't want you to do it that way. I want you to understand parallel processing. You're dealing with the arrays or whatnot, right? Okay, so back to binary search. So let's go through the algorithm. The pseudocode is above this, but let's go through the algorithm. So what's happening? We passing that one array, whatever, and then thinking your assignment is going to be the year. So we passing the year, and it's an array. When you see these brackets here, that means you're passing an array. You're passing the number of elements, the max number of elements in the array or your array size, and you're passing the value that you're going to be searching for. Okay? So in that main function, you probably had, please enter the number you are searching for. And so that was entered into value. So value was passed, the length of the size of the array was passed, and the actual array. All right. Now, look at this. It says int first equals 0. All right. So you're setting the first element to 0. And last equals element minus 1. So now what they're doing, they're trying to set it up to where what? When I start dividing my array, I always have a what? A first last. If I cut it in half, first last. If I cut it in half, first last. You understand? So I can know what range I'm dealing with, okay? Otherwise, I'm gonna be processing the whole thing each time, right? So it got you a first and last, and even a middle, all right? Because when you divide it in half, you got that middle point to check to see if that's the value. So, yes, sir.
Does odd numbers throw that off then? Like if the whole thing is searching for.
Look here. Look here.
Oh.
Yeah, so you see what I'm saying? Yeah, right. So yeah, it controls it. No, it'll control it. All right. And so you got your found again, you got your position again, like you had in the other one, right? So those are similar. Your found position and your found and your position are values. Then what? While not found and first is less than last. All right. So until what? When they all the same, then what? Then you didn't exhausted the search and you didn't find it. Okay. So you're checking it, and eventually you're gonna end up having the first and the last equal the same one. And if that's the case, you kick it out. But look, what you're gonna first do, middle is equal to first plus last divided by 2. So that's 0 plus whatever divided by 2, and then that's gonna give you the half of your what? Of your first start, right? And you're gonna keep moving on and on. Now, if array submiddle, so see that middle portion is that subscript. You got me? So you're gonna ask at that point, did I land on the value that I'm looking for? Right? If I did, I'm doing this swap. Right? I'm doing this swap where I'm putting found is equal to true and the position is equal to middle. So now I found the value, the subscripted value, and now I can go back to the main and print what? That row of information. All right. But if not, it says if array middle is greater than value, then I'm setting last to equal middle minus 1. All right. So last gonna equal the middle minus 1, or if not, right? If it's less than, I'm gonna set first to equal middle minus plus 1. So see, I'm gonna work with 1/2, or I'm gonna work with the last half or the first half. Each time I go through, it's gonna cut it in half, cut it in half, cut it in half. Now, I'm gonna tell you, don't try to modify this code. It works. You understand? This code works. So you shouldn't be trying to, how do I say, modify the algorithm. If anything, you're trying to understand the variables, or maybe changing variables to where you might understand it a little better. But don't modify the algorithm, because you're might throw everything off. All right, because the algorithm does work. Okay. All right. So, and like I say, once it finishes, it'll take position and return position back to the calling function. And then now you can use that position to say, this is the record I'm printing out. But if it's what? Even if it's -1, if position is negative, yeah.
Hey, that piece of code right there where it says else if array middle greater than value. If it's greater, let's say we're looking for a 10 and we have an 11.
Right,
So,
okay.
and then it says, then it modifies last to middle minus 1. That doesn't seem right. I think the two are interchanged. Because if that's the case, it should be in the second half.
No, but this one says the last to check the lower half of the array. You understand? Because you're gonna check the middle. Middle, you look here. Why is that here?
Yeah, if it's bigger than the value, we should be checking the bigger part.
Look here. Look here.
Yeah.
Look. You got less than or equal to for the last.
Yes, sir.
So that's included into it. And here, where's the middle? Last gonna equal the middle minus 1. So see, when you divide this and you're gonna get middle, you're gonna throw it back 1. Otherwise, you're including something you already done checked. You understand?
Yeah, but if we check it, like let's say we're looking for 10, and we find 11. So that 11 is in the bigger part, not the smaller one.
Right, but look what they did though. Middle is first is equal to middle plus 1. So
yeah,
now first is in the level.
That's not in the same section. You see what I'm saying?
Yeah, right here. This here.
Look, it says else if array middle greater than value, and then it puts it if it's greater than the value, it puts it in the lower half instead of the higher half. Maybe I'm reading it wrong.
Right. Look, it will say if array middle.
Yeah, right there.
Right. Now, when it say array middle, middle is not the subscript. It is a subscript here, but array middle is the value that's at that location, which is 10 you asking about. So
yeah.
So is 10 greater than value? No, it's not. 10 is equal to value.
Right. But let's say we have 11 over there, okay?
Right, but listen what I'm saying. That's what
so
I'm saying.
If 11 is greater, it's going to send us to the bottom half instead of the upper half.
No. Look, 11 is greater than 10.
Yeah, and then it sends us to the bottom half.
No, it doesn't. This is the true part.
Okay, you know what? I'll have to do the code. I'll have to do the code and see how it works.
Right, but look, if array sub middle, which is 10, you said 11, right?
Yeah.
Is 11 greater than 10?
Yeah.
Right. All right. So if 11, which is middle, is greater than 10, so now we're setting the last to middle. All right. Now this is the value 11. This is the location minus 1. You understand?
Yeah, but that sends it to the bottom half instead of the upper half.
I see what you're saying, but yeah, the first,
Anyway, I'll run the code and see it.
right, but it's correct though, because if array submittal, like I said, we're looking for 10, we look at, well, this is 11. 11 is greater than 10. No, it's not. See, but you understand what I'm saying? 11 is not greater than 10. So that makes this false. So it's going to do this. You understand?
Yeah, I think I confused
Well,
myself.
Yeah, 11 is if array submittal, which is 11, is greater than the value of 10. But no, look. But if 11 is greater than 10, then we're not dealing with the upper half. We're dealing with the lower half, right? Wait. If array middle, which is 11, is greater than this, all right? It is, okay. If 11 is greater than 10, no, but that's right. That is correct, though.
Okay.
Let's see. Half of the array element, right?
Okay. When I run it, I'll just put some cout statements.
Right. You see, yeah.
See what's happening.
Right. Okay. And then you could also look at the book itself too, and its explanation. All right. That's at the top. Wow. Right. All right. So now, cause see here, says the last submittal. Okay. Yeah. Right. The rate is greater than the desired value. It said this. All right. And that's just the way it works. See here, if the array submittal, which you said 11, is greater than the desired value, all right, then it set the last to middle minus 1, all right? So the middle, whatever that value is, it's going to set it to minus 1. Now, but, right. And this, because see what's happening, you got the middle. When you find the value, when you check the value, all right, you're checking if it's greater. If it is greater, you're setting the middle to whatever minus 1. Right. Otherwise, you're setting first to middle plus 1, which checks the upper half, which is what you're supposed to. But this is all right. All right. But you could check it though, all right? Mr. Casimir. All right. Yes, sir.
I think in that example with 11 and 10.
Right here.
No, I'm confused myself. If middle is 11 and you're looking for 10, that minus 1, the next time it runs with the minus 1 on middle, you'll find 10, right?
Right.
So it's in the lower, it's in the like.
But it'll be in the lower half, yeah. Right. That's why I say it does work, because it's gonna move you to where it's gonna check less than or equal to whatever, and it's gonna find. Because like you were saying before, if it's an odd number, what will it do? So the algorithm is set to where if that number is that close, plus or minus 1 is gonna find it and not skip over it. Yeah. All right. But that's your algorithm. All right. And then now this tells you the benefits of using binary over linear minus what? Sorting. All right. So it tells you what? A maximum of 16 comparisons will be made on an array of 50,000 elements. All right. So that's considerably less than trying to check what? 1 at a time to say, oh, it's not found in the array. And you done check the array, what? This many times, 50,000 times, all right? The process of it, all right? Whereas this one just only did what? 20 comparisons, and it's finished, all right? So it's a lot quicker, all right? Now, sorting. Even though a linear search does not require sorting, in your program, I have you doing a sort before you do your linear search. Okay, so you don't have a sort and a search, a sort and a search. Two different programs, two different sorts and searches. Okay, so just to get you the feel of doing sorts and searches. Now these sorts, the searches, the prints, the gets, I think also all need to be what? In functions. All right, so your program should be broken up in functions. While you're reading the data from a function, you are sorting the data in a function, you are searching the data from a function, and then you printing the data from a function. So you're calling all that from the main. So you're going to be returning values back to the main function so that you can do the things you have to do. All right, so sorting algorithms are used to arrange data in some order, whether it's high, low, high, etc. All right, now to sort, all right, in an array, programmers must use an appropriate sorting algorithm, okay? A sorting algorithm is a technique used for scanning through an array and rearranging its content in some specific way. And the two that we're going to use, like I say, is bubble sort and selection sort. Like I say, there's many other different algorithms out there, but these are the ones that we are using, all right, in the book. Now, so a bubble sort. How does the bubble sort work? To give you an idea of what's happening, the bubble sort, all right, is an easy way of arranging our data in ascending or descending order, okay? And we know that ascending is from low to high and descending is from what? High to low. So, given the following array, say like if you had an array of 6 elements and it was 7, 2, 3, 8, 9, and 1. And we need to rearrange this to what? 1, 2, 3, 7, 8, 9. In what? Ascending order, right? Some sort of order. The bubble sort starts by comparing the first element in the array, all right? And if the first element, all right, which is 0, is greater than the second element, well, which is the 1, then it does what? It swaps. And it does that. It goes through and keep doing it over and over till there's what? No more swaps. But understand. So what happens is, so it says the second method is repeated with what? The first element and the second element. So what happens? It compares 7 and 2. If 7 greater than 2, it's going to do what? Swap. So swap is true. So you keep going. It's going to check to see if 2, it's going to be, if 7 greater than 3, right? Well, it's going to go through that. If 7 greater than 3, if 7 greater than 3, it's going to do the swap. Then it's going to check to see if 7 greater than 8, no swap. If 8 is greater than 9, no swap. If 9 is greater than 1, it's do the swap. Then it starts what? All over again. Is 2 greater than it's 3, right? Nope. Is 3 greater than 7? Nope. Is 7 greater than 8? Nope. Is 8 greater than 1? Remember that the 1. So then it was swap. It's going to keep doing that swap until 1 gets to the beginning, and then the last time through is going to go through it, and if there's no swaps, then everything is in order. That's the way that sort works. Okay? So what it says is the next time, whatever. So what happens is that 1 is going to keep being swapped because everything is pretty much in some kind of order, but they're not in the proper position until 1 get in position and push everything else back. So it's going to keep swapping the 1 with the 8, then the 1 with the 7, then the 1 with the 3, then the 1 with the 2. Then it's going to check again and say, oh, nothing was swapped. So therefore what? Everything is clear. It's sorted. All right. So that's how that works. And like I said, the sort repeatedly passes through the array until no exchanges are made. Ultimately, the array appears as follows. So remember, by 2, it just keeps swapping till everything is arranged and there's no more swap, and then therefore it's finished. Now, that's how it works. But let's look at the pseudocode. Okay? This is the pseudocode, all right? Now, they have it to where what? I don't care what you're doing. When you are dealing with data, you can't take for granted that what? Oh, well, it might be already sorted, right? So what they have, they don't have a while, they have a what? A do. A do says what? Perform this at least one time. So if you get a file and it supposedly is sorted, the do will automatically go through it to see if it what? It has to swap. If it don't swap, okay, cool. All right, everything's straight and we moving forward. But if by chance something is not, then what? It'll go through and sort it until everything is in order. All right, so that's why they have the do. All right, so now it says set swap flag to false. Swap flag gonna stay false until we do what? We do some changes till we swap data. So whenever swap is true, we staying in there. We staying in there. We staying in there. As long as we swapping, we just continuing through that loop. Then all of a sudden, when swap is false, we kick it out. All right. So we're gonna kick out that loop. All right. Now, so it says for count, set each subscript to in the array from 0 to the next to last subscript. All right. Now, this is very important. Why does it say next to last subscript of the array? When we doing our checking. Anybody just offhand? All right, let me page up if I can. All right. So say here, say this is our last time through. Well, not even, say it's our first time through. We're gonna check this to this, correct? This to this, this to this, this to this, this to this, right? The -1, which is what? Which is 4. Now, but if I try to check this to something out here, that's when you went out the boundary of the what? Of the array. So you understand? So once you check that one less than to that one, that's it. You start back over. You don't try to check the last one and try to go out of bounds and check another one beyond that, because you're reading another address that's not a part of the array. All right. So that's one reason for that. All right. So now it says the array subcount. If the array subcount is greater than the array subcount +1, then you're gonna do the swap. That's when you're checking to see if the first array position is is greater than the second one. That's when they swap. Because what? Array subcount. Now look at this. You might be confused with this. Array subcount +1. This says if count is 2. This says array sub 2, and this will say array sub 3. Right? You got me. So it's not looking at the actual value in the array. When you have these brackets, it's the subscript. Everybody understand it? So don't get confused with saying, oh, well, the value is this and the nope. Count here is the actual array position. Count +1 is that array position +1, right? So not the value in that array, right? All right. So now, so and then you do the swap, and that's done. Now, here is a program. You might not be able to see it too good either. Let me bring it down. So now this is an actual program, and that's in the book with an actual sort. So if you look here, you got your sort array, you got the array that you're passing, and you got the size that you're passing of the array. And look, swap, all right, Boolean swap. So you created a bool value, all right, int temp. Now, you created a temp value so that what? If let me put it like this. If I wanted Mr. what? Travana. If I what?
Shabaita.
No, man, how you say it?
I mean, my first name is mine.
No, what's your last though?
Shabaita.
Shawaitan?
With a B. Shabaita.
Shabaitan.
Yeah.
Okay. If I wanted Mr. Shabaitan to change position, change shares with Mr. Booker without them having to be standing up. Oh, let's say that. I want them to swap positions without them both having to be standing up at the same time. I'll put it like that. What would I do? How would I have to do that? I want Mr. Booker to be here and Mr. Shabaita to be in Mr. Booker's seat. How would I do that? Without them both standing up at the same time. I would have to get a third person, a temporary, or say somebody have to be in the seat at all times. I'd have to get a third person and maybe let Mr. Booker stand up, let that third person take Mr. Booker's seat. Mr. Booker walks over to Mr. Shabaithon, that's right, Brython. He gets up and he sits, and then Mr. Shabaithon moves to the other position. He gets up and let Mr. Shabaithon sit. You understand? So it's almost like you got to have an extra position to say, hey, I want to take element 1 to put in 3. I'd have to take element 3 and store it, and then put 1 in 3, and then take the temp value that I had in which was 3 and put in 1. So that's why they have a temp value here. So when I do this swap here, let me get to the algorithm. I'm not the algorithm. I don't cast it up. Yeah, so here, if I gotta move 5, 7, or what not say, yeah, not this one. If I have to move, not that one. No, I want the others. That was the one, but I did, it was already in order. Yeah, so now here, if I had to move, it's already, okay, here. Yeah, I need to move 7 to where 2 is, all right? So I need to take element 1 and put in element 2, right? So what I have to do is, one or the other, take element 1, store it in a temporary location. Otherwise, I'm gonna what? Lose it. You got what I'm saying? So I store it in a temp location, then take element 2, well, no, where I'm at, on that 1. Then yeah, take element 2 and put in element 1, and then take the temp element and put in element 2, so I won't lose it. So that's why when you saw that temp value was holding that value because you had to put it aside until you swap, you move something into it, and then you move that temp value into to replace that other position. Okay, so that's why that was done. All right. So when we go back to this here, let's see. Yes.
So you gotta use the temp.
It's a variable. You can call it whatever you want. Yeah.
Temp variable because like a CPU will only do 1 instruction at a time.
In a sense, correct. Because now I think there is a command to do a swap. I don't want you to use that. I want you to use the algorithm, right? But and it makes you just understand that, hey, sometime I might take this and put here and I've lost it. So I need to create that temp value, store it, move that, then move this back, right? But
even that swap command would probably do the same, right?
well, yeah, the swap command should just swap it, but don't mark me on it. But I think there is a command where you can swap. And now, given this, most times the different commands that are or even functions that are within an application or a compiler is the actual code that does that. It just does it for you.
Right, it's like a little short.
Right, that's right. Somebody have already written that particular algorithm for you, so you don't have to write it. Right. So it'll take it, put it in a little memory location, take the other whatever, and it's done. But you just saying swap this with that. Right, right, correct. You just have to know the syntax. So that's the code for swapping. So when you write your code program, you can look at that for an example. Look at array vectors. Now, I think your programs, one of them going to have to be written in arrays and one's going to have to be written in vectors. I think if I'm thinking straight. Class over? Yeah, I know it's over, man. I tell you. Look here. This is the pushback function. All right. Now units would be my vector. Now what happened here is, let's see if I declared anything. No, it's just showing the example. So let's look at it. And like I was telling you at the beginning of class, dealing with vectors, all right, here, the vector probably was right here, look. Let me move this down. All right, so look, so here we have, let's just say inputting information into a vector. So it says for int value equals 12, all right, value less than that. So all it's doing is doing a loop that's gonna start at 912 and end at 522 at 912 and then at 922. All right. But what it says is every time I run through this loop, I'm gonna do a pushback and store a value into my vector called ID. That's all that's happening. Now, previously, you don't know where it started at, but if the vector was empty, it's starting at 0. If it wasn't empty, if it wasn't empty, then what? It's starting at the very end and adding to it. You got me? So the pushback, you can use the pushbacks with a vector already, with data already in it. It's just gonna grow, right? A vector that's empty, then it's gonna start, from 0 and continue on. Now, once data is inputted in a vector, you treat it just like you would an array. You just manipulate it using subscripts. But vectors have other functionality other than arrays that goes along with it. Now, when you use vectors, you have to load the header file. File include vectors, all right? You got to do that, all right? So make sure you do that, all right? So you can initialize vectors, and what this does, but what you can do, you could create an array size or an array. This is initializing an array, but then what? Take that array and store it into the vector, right? So you could do that like if you needed to at any time. Oh, I got this array, whatever. Boop. Hey, create that vector, the loop, throw that data in that vector, and now your vector can grow, shrink like you want. All right. Now, passing data, right? Look here. You got void int. Now this is a vector function that's going to be defined. You got, this is the name of the function, int vector. But in that function, I got a vector of integer, and I'm using the reference symbol where I'm referencing ID, okay? Right, so I'm gonna pass ID by reference, meaning what? Whatever I do to ID in my function, gonna automatically be done in its original location. I'm passing a vector of int by reference called units. And then I'm passing a vector of double, all right, by reference called prices. So that's all that's saying, all right? So just like you pass an array, you could pass a vector, same way, right? Just like you pass a single variable, you could pass a single variable, right? So this vector is called ID, this vector is called units, this vector is called prices. Simple as that, all right? Now, if this same information here, if this the definition of a header file for header function, header for the function. Here, if you wanted this to do the prototype, meaning like you do your prototype at the beginning and define your function at the end, this is what it'll look like. Void int vector, right? Then vector int ampersand. I'm passing a integer vector by reference. Vector int ampersand. I'm passing an int vector by reference. Vector double ampersand. I'm passing a double vector by reference. So you see how you set it up so that it matches. Because what happens, you're gonna get linkage errors. Like you're gonna say link whatever. If this is sometime out of order, or even this is one short of this one, you'll get those type of errors. Okay. And this is how you call the function. Just like, I mean, the vectors. Just like when you call variables or arrays, you don't have to put the what? The square brackets for arrays when you passing that or passing that array when in a call. You just put the name, right? And the same thing with vectors. You just put the name of that vector, like from if you in the main, you declared it and or whatever, or did what you had to do. When you passing it to that calling function, you just give the name of that vector, and that's that. Okay. And like I said, you could do a vector, a variable, an array, a variable, you know. So you could pass whatever you want, as long as you have them in a proper order, right? And set up proper. All right, any questions? Now, the assignments. And let me look at Canvas, because I think we might have, I think this is like a couple of weeks. Well, my margin. Okay, so this is, yeah.
Oh, I didn't mean to interrupt you.
Oh, no, you're all right, you're all right. So, yeah, Thursday we'll have class, and then next week we'll have class, but you can, did I open it? But you can start on your programs, all right? Now that first test is open, it'll be open until, what did I?
29?
Sunday. Yeah, right, it's open till Sunday. Now, but these assignments you can start on, and what I'll do next class period, at the beginning, I'll go over the assignments and explain to you exactly how, what I want, whatever, however. Even though you can start on them now, you know what I'm saying? You can start on them now, but at least I could give you a little more insight. You're like, oh, I thought we would just do this, or where do we do this, or do I have a data file? My data file should look like this, or what, stuff like that. Okay?
I just gotta hit the work.
Okay, what you got?
No, I just
Oh, all right, no problem.
I just wanted to let you know, I didn't wanna-
Oh, yeah, you cool, you all right.
Appreciate it.
All right, have a good one. All right. Anybody with questions? So like I said,
Professor Sylvester,
huh?
Professor Sylvester.
I got you. What you got?
Hey, yes, sir. Look on your on that assignment page on Canvas,
All right, I'm on
way
camera.
at the bottom, there's 2 quizzes on arrays, but it's set to unlock December 31st.
Wait.
I don't know if that was something you wanted us to do or not.
Wait, what week that is? What
It was the last thing on our assignment page. It's like the last thing at the bottom.
no, but it's not published on.
How?
That's not published on.
That's not part of the assignment.
It's right, 'cause it's not being, it hasn't been published, correct?
Wait, hang on. Let me find the exact location so I can tell you.
Right, but I'm saying it hasn't been published, correct?
No, it's there, but it says it starts December 31st. Both quizzes on arrays.
Right, but I know, look, if you want to see what I have available, go to modules.
Go to what?
Modules on Canvas, go to modules.
Okay, modules, okay.
Right. Because all that other stuff, there's other stuff that's out there, but I don't publish everything. You got me?
Okay, got you.
I use it as needed, you understand? But yeah, no. Yeah,
Okay.
you'd only do what's published in modules.
Okay, understood.
Right, you got it? So it's not showing up in modules, correct?
Yeah.
Right, all right, that's good. What you got?
Southeastern, so we did Java and .NET. I've been struggling with the C++. Like
Okay.
logic is easy. Just
But that
the-
code, you know.
Yeah, well, just like the syntax and everything, and then like the data file and F stream. I didn't. That like went.
All right, because you still got time to turn your program tonight, though.
Yeah.
Okay.
Yeah, I'm about to head to the library. I'll be
All right, yeah. So you got it, Mr. Casimir?
I got it, sir. I got it.
All right,
I
okay.
got a much clearer view.
Right. That's what I'm saying. They're gonna give you just what we have. It got the dates on it and whatever. So, like I say, that other stuff, even if you go to syllabus, it's gonna show everything that's out there, you know, but all of that is not going towards your grade.
All right.
Right.
Yeah.
Right.
Okay.
All right. But it could be something though. Just keep me in mind. I mean, if you see something that you think, hey, Mr. Vesta, I saw such and such, then I could double check to make sure, because I don't want nothing to go against you that I forgot to add or didn't do whatever, publish, and I'm
Yeah, I was just checking. And
Right.
I have a question for you about Linux, but I'll wait till everyone else is finished
All
since
right.
it's about another class.
All right. Yeah, let me deal with Mr. What? Cameron right quick. Oh, let me see where I'm at. Oh, I thought I had visual.
Is that a Surface laptop?
Yeah.
Or a Best Buy? I saw a
You-
lot of those.
Oh, yeah. So let's see. If I open up, I'll open this one up. I think this one might have. All right. So now, you in a class that's coming in?
Yeah.
Oh, you can have a seat. No,
I
Miss
know.
Miss Della or someone?
Uh-huh.
Yeah. Oh, okay. Hold on, man. I think I
You
know you.
remember me,
Yeah.
It's been a while, it's been a while. I know.
Yeah. She didn't have class last week, though.
No, sir.
Right. All right. So here, let's see here. All right. So this is the file, right? Let me see. Let me open it. Why not open it? Oh, there you go. See the file. Oh, they got more than one.
Is this a class or a computer lab?
It's a class. You come on in. All right. So look. All right. So now you say the data file, correct?
Yes, sir.
All right. So with the data file, say I have this here. To add a data file, you using visual?
Yes, sir.
All right. To add a data file, what you can do, you can go to any one of these. You go to resource file. Even you could go where's text. I think it's an external. No, not external. But resource source file. Like I right click here and do add, do new item. Now, at this point, this is where you can do a header file if you choose to, or another CTT, but you go to utilities. Go to utilities and a text, you just want plain text.
Okay.
Right, because I don't do the binary well.
Yes, sir.
Now, so here, you give it a name, if it's text or .txt, and you do add. And see, yeah, it should show. Let me see something. Yeah, see, it should show. Yeah, see, it's up there.
Okay.
So it's text.txt. So I could click on it. Should be able to click on it. Yeah, and it's empty. So I could put something in there like, all right. So I put 1, 2, 3, 4, 5. Now, go back to my file itself. In this file, I need to, when I use a file, well, my external file, I need to do pound include F stream. Got to have that.
Okay.
That let me know that I'm gonna be either reading or writing to a file.
Okay, understood.
Now, I need to create an object so for my file, so like for input or output, like for C out or CN.
Yes, sir.
Because I'm either gonna be reading to that file, reading from that file, or writing to it. So I'll do an IF stream because I'm gonna be reading from it and give it a file object, and I'll say in data. So now it's right. No, in data. All right. So now that's my object. So now inside of here or wherever I'm gonna read the file from, I need to do the object in that. Oh, man, it's messed up. In data.
I think you deleted an A on in data.
Oh yeah, so there go. In the semicolon. Yeah. Okay. All right. And so I do in data dot open. I have to open the file if I'm going to use it.
Okay.
And parentheses and whatever the file name is text.txt. Now, as I told you, in Unix, this file has to be exactly like this because it's case sensitive. On a DOS system, it could be lowercase tx, it doesn't matter, T or whatever, it doesn't matter. But you might want to get in the habit of making it as case sensitive so you don't run any issues.
Yes, sir.
Now, I open it as input, and now this is the input file. So now what I can do, I think I have 4 int. I'll just do this, and I know I got 5 records. I'll say x equals 0, x less than 5, x plus plus. Now, what I'm gonna do in data, which is rather than do CN,
Mhm.
and I'll say, let me create a variable. I'll say int. Okay. So what I'm gonna do, I'm gonna just read it in and write it out so you can see. And I think I have a help video too
Okay.
in data. No. All right. Then I'll do C out. And, okay. So now, got that. I'll just take this off. Whatever this is. Take that off. All right. So now I have this small file. Like I say, got a text file, reading from it and writing out. So let's run it, see what happens. So I'm gonna just do the debug because I think it was already. Oh, I'll do the compile. I'll do a compile. It's gonna tell me down here what it finds in it, find any errors.
And are those little arrows right there?
It failed. It failed. What that?
Are those just assigning, saying in like num is in data, whatever you find in data is what num is?
Well, in data says that's my object that's gonna read in.
Okay.
Whenever I do in data, I'm going to that file.
Okay.
That's what, because rather than do C out, I mean CN. CN says I'm what? Inputting it from the keyboard. You know what I'm
Okay,
saying?
so that's
Right.
like system.in on Java. Okay.
Okay, yeah. No matching to. Oh, you know what I didn't do? Close curly brace. Okay. All right. So now when I debug it, well, let me compile it. It should run now. So now it's gonna say, should say nothing. Okay, one succeed, and then when I do the debug, okay, and it should give me those numbers. It'll be spaced out though. Yeah, see, look.
Okay.
And if I do this, if I look at my text data and go back to here, see, 1, 2, 3, 4, 5.
Yes, sir.
So it read from it.
Okay.
Now, if you look here, this your first day?
Well, third day, yeah.
Okay, you signing a roll. Well, you signed a roll on,
Yes, sir.
on 2.
I wasn't here. I emailed you. I had work.
Okay.
I had work.
And look, ain't no problem. But and like I said, I'll try to put the stream.
Yes, sir.
So like if you can't make it, hey, go on the stream and ask
Yes, sir.
questions or whatever.
100%.
I don't have no issues with that.
No, it's just when I came from Southeastern, because I got to like my junior level. So I'd already taken,
a lot of the programming classes. Yeah.
So they didn't need to put me in 1933. Is that what it is?
Yeah, right. That's good.
So I think I'm just translating Java and .NET to
Right.
C++.
Right. Now look here. If you look at, I think, scroll down here, how-to videos, and yeah, it's gonna take you to my YouTube channel.
Yes, sir.
And from here, it should have a list of signing a role. See, look.
Oh, wow.
Yeah. Creating a data file in Visual Studio.
Okay.
You know what I'm saying? Creating a file visual. So it got a little bit of help where you can say I could follow it and whatnot.
Yes, sir. And then sorry to take up too much of your time, but that header file, that's just the function names, right? Like all the stuff that's being used in the.
No, look, the header file, if you look at, if you go back to, let me stop there. If you go back to, where is it? It's more, let me go back to here. You go back to here and 194. I should have went to Canvas. I think I got it in Canvas. In Canvas, that's it. In Canvas, if you scroll up, I think I have in announcements. Let's see, I think it's in announcements. Go to announcements, and in announcements, come on, yeah. In announcements, okay, creating a header file for assignments.
Okay.
See, so you click on it, and it's going to show you. Now, it's no, I don't think it's a video, but it'll show you. Use the following example to create your header file.
Yes, sir.
Name it, .a, whatever .h.
Okay.
And then this is the information you put in. Now, looking at that, this is the example, C++ file.
Mhm.
So if you look at this is the header file called header.h. So when I want to load this header file, all I do is pound include in my CPP file
Put header eight.
in double quotes,
Parentheses,
right.
header, double
When I wanna execute this function here
Mhm.
called head, I just do what? Head, open, close, semicolon, because I'm not passing variables or nothing.
And you're not creating any functions, you're just pulling in the functions from the header. Okay.
That one, but
Yeah,
those,
that's specific.
right, but,
Okay.
but no, and the other functions you're gonna be creating in the CPP, like,
sir.
okay, you got it?
Gotcha. Yes, sir. Thanks,
All
sir. I
right,
do
so you can
appreciate it.
use those for reference.
Yeah, I'm gonna hop on. I'll be in the library.
All right, man.
Thank you, sir.
All right. Mr. Cashmere,